Podcast script, The Ministry of AI. Episode, Understanding the Strengths and Weaknesses of Conversational AI in Code Repair. Welcome to the Ministry of AI, your go-to source for the latest breakthroughs in artificial intelligence. Today, we're diving deep into the fascinating world of automated program repair, how large language models like ChatGPT are evolving to fix bugs in code and where they still fall short. Our focus? A recent study titled Studying and Understanding the Effectiveness and Failures of Conversational LLM-Based Repair by Chen, Wu, Xin, Reiss, and Xuan. It takes a critical look at how well conversational AI systems perform when tasked with fixing buggy code and explores why they sometimes fail. AI-driven program repair has seen massive progress, but as we'll uncover, there's still a long way to go. Let's start with the basics. Automated Program Repair, or APR, is designed to reduce developers' workload by fixing software bugs automatically. Conversational AI, especially ChatGPT-powered techniques like chat repair, has become increasingly popular for this task. These models don't just generate a repair, they also provide explanations and can iteratively refine patches to improve accuracy. But here's the issue. Despite its power, chat repair fails to fix more than half of the bugs in the Defects4J dataset, raising the crucial question, why? The researchers conducted an in-depth study comparing two strategies: close-style repair, which targets specific lines of buggy code; full-function repair, which updates entire methods. Surprisingly, full-function repair was more effective. Closed-style frequently produced non-compiling code. Even more interesting, the iterative approach, meant to refine patches over several attempts, didn't actually make repairs more accurate. In fact, independent single-shot patch generation performed just as well, if not better. What's causing these failures? Three major problems stood out. 1. ChatGPT struggles to understand the root cause of bugs. If it misinterprets the problem, its fixes are often useless. 2. It lacks knowledge of expected program behavior, essential for making effective repairs. 3. It fails to find the right fix ingredients, especially when key components are outside the buggy function. These insights suggest future improvements should focus on better understanding of failure causes, clearer expected behaviors, and smarter retrieval of relevant code elements. In short, conversational AI has made exciting progress in program repair, but it's still far from replacing human developers. This research provides valuable clues on how to make AI-powered debugging more reliable and precise. Looking ahead, we'll likely see better integration of AI with human feedback and smarter strategies to guide these models. Thanks for listening. If you found this valuable, please like and subscribe to our channel. To advance your AI knowledge further, check out our free courses at the Ministry of AI. You'll find the link in the description below. Until next time.